Objective number 2. Analyze a piecewise defined function. A piecewise function is the function that has different domains. A part of the function has one domain and another part of the function has another domain. For example, number 3, we have a piecewise function f of x equal negative 2x if x less than 0 and square root of x if x greater than or equal to 0. This is the domain that I'm talking about, x less than 0 and x greater than or equal to 0. So let's give some example for x less than 0. They are the number that less than 0. If you draw the number line right here, we don't take at 0. We will have any number that from 0 to negative infinity. Or you say from negative to 0. And for the second one, the x greater than or equal to 0, that means starting from 0, go to positive infinity. Like 1, 2, 3. And for the first one is like 0, negative 1, negative 2, negative 3, and so on. In part A, they asking us to find f of negative 4. We look at the input negative 4. The input negative 4, we will use the first piece because negative 4 is in this domain, is less than 0. So we will use the first piece. We plug into the first piece. So negative 2 times negative 4 and is equal to 8. F of 0. 0 is in the domain of the second piece because in the second piece you see that it's greater than or equal to 0. So second piece including the 0. So we will plug into the second piece square root of x. So square root of 0 is 0. And f of 4. So 4 also in the second piece, in the domain of the second piece, 4 greater than 0. It is in the interval from 0 to infinity. That's why we will plug 4 into the second piece. So square root of 4 is 2. So in this problem, we just need to look at the input to see that number belongs to which domain. When it belongs to which domain, then we would choose the piece, which piece to plug in. In f of x, we have two pieces. Then you look at the domain to choose which one to plug in. In problem B, find the domain of f. The domain of the first piece is from negative infinity, 0. And the domain of the second piece is starting from 0 to infinity and including. The domain of f is the union. Union of these two domains is the whole line, negative infinity to positive infinity. Locate any intercepts. You recall that the intercepts, we have two intercepts, X-intercept and Y-intercept. To find the X-intercept, we will let f of x equal to 0. And to find the Y-intercept, we will let x equal to 0. If we let x equal to 0, then the x is in the second domain. So we will plug x in the second one. So f of 0 equals square root of 0 and is equal to 0. So we have the point 0, 0 is the y-intercept. For the x-intercept, we let f of x equal to 0. Since the function f has two pieces, then we have to let the two pieces equal to 0. So negative 2x equal to 0 and square root of x equal to 0. we divide both sides by -2, then we will get x equal to 0. And the second piece also x equal to 0. What do we see is that when x equal to 0, from the first piece it does not take. For the first piece it does not take 0. You remember the domain of the first piece is from -infinity to 0 but not include. So this one is the first piece and we eliminate this one. So the x-intercept is 0, 0. Okay, so problem D, we need to wrap the function f. Let's write out the function f one more time. F of x equal -2x if x less than 0 and equal to square root of x if x greater than or equal to 0. What do we need to do is we will make the table for two pieces. So this is like a two problem. So x and f of x equal -2x. So that is the first piece. We keep in mind that the domain of the first piece is less than 0. We need to begin from 0, and you know that this point is the open point because 0 is not in the domain. And then we make the points that less than 0, so we can make like -1, -2, -3, -10, and so on. You notice that that is the equation of the line because the exponent of the x is 1. So this is good enough that we can make only 3 inputs, okay? So we plug in and we get -2 times 0 is 0, -2 times -1 is 2, and -2 times -2 is 4. So let's go ahead and wrap the first piece. For the first piece, 0, 0, and we will have this point is open because once again the domain of the first piece does not take x equal to 0. So we have that point, but we don't have it closed, okay? So that point is not on the wrap for the first piece. -1, 2. -2, 4. And then we connect those points. I will continue to extend on the left side because we actually can make more like -3, -4, -5. So we're done with the first piece. Now we will make the table for the second piece. For the second piece, f of x equal to the square root of x. And the domain of the second piece is starting from 0 and more. So we're gonna make 0, 1, 2, 3, 4, 5, and so on. So let's start with the first two input. Then we got the answer is 0 and 1. You notice that this is the square root. If you don't want to use the calculator, you can make 4. Then square root of 4 will give you a nice answer, which is 2. So 0, 0, 1, 1, and 4, 2. So we get the graph of the function f with two pieces. And for problem E, we look at the graph to find the range of the function f. The range of the function f is the y, consists of all of the y. So we look at the lowest for y part is starting from 0 and the graph go up. So the range is from 0 to infinity.